Okay, so in this video, we're going to talk about the unit circle. And this video is primarily an introduction on what the unit circle is. So it's not what the entire concept is all about. So we're just going to go over understanding what is the unit circle, how to use the first quadrant of the unit circle to memorize all four quadrants, and we're going to apply it through practice using a trick, okay? And that's going to be called the the quadrant one trick. So here it is. This is the unit circle that most students fear. Unfortunately, it's nothing too crazy to look at. I know you're looking at this right now and you're probably wondering, how am I supposed to memorize what is that 225 degrees or 5 pi over 4 radians, or what is that 135 degrees 3 pi over 4 radians? But as we go over this video, I'm going to show you guys a few tricks. First and foremost, when you're looking at the unit circle, there are a few things you need to acknowledge. When you're looking at the values here, this x and y that you're familiar with is no longer x and y on the unit circle. In fact, we'd like to call it cosine theta and sine theta. All right, so just remember, x is related to cosine theta and y is related to sine theta. That's primarily the only thing you're going to need for this video, and as we go through it, it'll make a lot more sense, hopefully. Now, let's go ahead and look at this magical trick that I've devised, or not really devised, but more like I've used when I teach this subject. Now, first things first, I kind of took out a quarter of the unit circle only. And in fact, the only quarter that I took was the quadrant 1. So just to go back very quickly right here, if we're looking at this unit circle into 4 pieces, the green represents quadrant 1, the yellow represents quadrant 2, the third represents quadrant 3, and the fourth is, of course, quadrant 4. Now, when we're looking at the quadrants of the unit circle, or just the Cartesian plane in general, we look at it in a counterclockwise motion. So quadrant 1 starting from the top right, quadrant 2 top left, quadrant 3 bottom left, and quadrant 4 bottom right. So counterclockwise. And you can also make the observation here that the angles are increasing in a counterclockwise direction, but that's for another video. Now, to show you this quadrant 1 trick, you need to know what each quadrant represents, okay? So first, I drew this little chart right here on the left side where it says A, S, T, and C, and it's divided by 4 parts. In fact, these 4 parts represent the 4 different values that are positive in these quadrants. So in the first quadrant, we say that all is positive. So all is positive, meaning the sine and cosine are positive. In the second quadrant, sine is only positive, meaning cosine is negative, and other implications can be made later on. In the third quadrant, tangent's positive. Now, I know this video doesn't really talk about what tangent is, but a brief review of tangent would have been tangent of theta equals sine theta over cosine theta. And you can probably deduce at this point that if tangent has to be positive, then sine and cosine have to be both be negative. So sine's negative and cosine is negative. And the last quadrant, cosine is positive. And sine is negative. Now, using that introduction, this is going to be a lot more helpful now. Now, looking at the first quadrant, if you see here, my angle starts at 0 radians or 0 degrees, right? And as we keep going, the angles increase up to pi over 2 radians or 90 degrees. So there's a 30, there's a 45, a 60, and a 90, which I should actually circle so it makes more sense for clarity. And in another video, I'll discuss what to convert these degrees, as we're more familiar with, to radian values. So here, the trick is, once you know the first quadrant, it's going to be easy. But to make it a little bit easier for you guys, if you look at the x and y values, or the sine and the cosine and sine values, right? So I'll just use x and y for the sake of clarity here. So x, and y. Notice that the x and y values are kind of inverse to each other in terms of like increasing and decreasing. So if you see that x is decreasing, then y will increase. So as you get to the very top right here, you see that the sine of pi over 2, or 90 degrees, the sine, the y value is 1, but at 0 degrees or 0 radians, it is 0. The sine of 0 is 0. So the best way to think about this is, okay, as x is decreasing, then y would be increasing. So if the cosine of 0 is 1, the cosine of 30 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2, and the cosine of pi over 2 is 0. Likewise, the sine values would then increase, right? So sine of 0 is 0, sine of pi over 6 is 1/2, sine of pi over 4 is root 2 over 2, sine of pi over 3 is root 3 over 2, sine of pi over 2 is 1. So you can see here that these values are increasing and decreasing in an inverse proportionate way. So as x decreases, y will increase in the first quadrant. Now, you're probably wondering, how can I remember all of this, right? How do I know what would be the sign of a value in the third quadrant, for example, right? Well, for starters, the mnemonic to remember with this ASTC is this. All students take calculus. Oops, that's poor handwriting on my end, sorry. ASTC. And each letter represents the quadrant. So the first letter, first quadrant. It's the first word, first quadrant. Second word, second quadrant. Third word, third quadrant. Fourth quadrant, fourth word. Right? Now, let's actually apply this to a practice problem. But before that, there's one more thing about this quadrant that I'm going to show you, which is called the family of angles. So, excuse me. If you remember from the unit circle, we were looking at a bunch of angles that had the same denominators, right? So the family of angles essentially represents the main three, or I call them the big three. So for example, the first family of angles would be the pi over 3 family. And in the pi over 3 family, obviously the first one has to be pi over 3. The next angle would be 4 pi over 3. And the next angle would be, whoops, I made a mistake here. This should be 2 pi over 3. So this here should be 2 pi over 3, then 4 pi over 3, and 5 pi over 3. And you're probably wondering, where the heck am I getting these angles? Okay, I'll show that later. I'll show it later with one of the examples. But first, here's a pi over 4 family. It starts with pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And last but not least, you have the pi over 6s. The pi over 6 family is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now you're probably still perplexed at how I got this, right? So let's look back at the unit circle very quickly. Right here. Let's say I take the pi over 4 family, right? So we see pi over 4 family right here. Now, the pi over 4 family can be found in each quadrant. So here's a 3 pi over 4, here's a 5 pi over 4, and a 7 pi over 4. Pretty cool, right? And if you look at this unit circle, each line is designed to be towards a specific angle. So each line on the unit circle here, the purples represent the pi over 4 family, the green dashes, I believe those are green dashes or turquoise, those represent the 5 pi over 6 family. But then here there's also the blue one. So I think it's just based on the coloring of the circle. But you can see that they're all connected somehow, right? Now, let's actually apply it to some practice problems. Now, let's look at the cosine sine values outside of the first quadrant. So first, let's look at the cosine of 3 pi over 4. So if I know the cosine of 3 pi over 4 is what I'm looking at, and I have my unit circle on the first quadrant here, I know I'm looking at the pi over 4 family. Now, because it's in the pi over 4 family, I know that I can assume that cosine of pi over 4 equals root 2 over 2. And remember, cosine represents the x value, right? Now, since we're looking at 3 pi over 4, 3 pi over 4 is in quadrant 2. And in quadrant 2, we assume that sine is positive and cosine negative. So therefore, we can conclude that the cosine of 3 pi over 4 is negative root 2 over 2. Okay, now the sine of 11 pi over 6. So first of all, we know it's going to be in the pi over 6 family. I'm not going to write that down just for the sake of clarity here. So the sine of 11 pi over 6 is found in the quadrant 4. Right? Quadrant 4 is right here. And in quadrant 4, we know that cosine's positive and sine is negative. Therefore, the sine of 11 pi over 6 has to be, based on the pi over 6 family, it is negative 1/2. The cosine of 4 pi over 3 can be found in, this is in the third quadrant, so Q3. And in Q3, we assume cosine negative and sine negative. Because both cosine and sine are negative, the cosine of 4 pi over 3 in relation to the pi over 3 family has to be, oops, I don't know why I drew that parentheses there. This has to be negative 1/2 as well. All right. Feel free to look at this unit circle again. Feel free to rewind the video as needed. Hopefully, this is a good introduction to what the unit circle is all about.